Hello everyone, welcome back to the channel. In today's video, we are diving into Python socket for Pentesters. We will also explore how you can use Python socket for creating a TCP client and also a TCP server. And before the end of this video, you are also going to learn how to create a reverse shell using Python. Now, before we begin, we need to know the definition of a socket. Now, before we dive into coding, let's quickly cover what sockets are. Now, in simple terms, a socket is an endpoint for sending and receiving data across a network. Now, when two systems want to communicate, they use sockets as a way to transmit data. And we have two types of sockets. So we have two types. Yeah, we have the TCP and the UDP. The TCP is the transmission control protocol, and the UDP is the user datagram protocol. Now, TCP is reliable and connection based, while UDP is faster but doesn't guarantee delivery. Now, if James were to send a message to John, James will confirm if John has received the message by by calling John, asking John if John received the message, and John will reply James that okay, I've seen your message. But in the case of UDP does not send any confirmation message to the sender. James just sends a message and concludes in his mind that the message has been delivered to John successfully. Alright, so as a pen tester, understanding these concepts helps you build and test network tools efficiently. Now, for the environment I'll be making use of the Python environment, and I'm making use of Python 3 for this tutorial. And also make sure that you have Python installed on your machine and fire up your terminal or preferred code editor. So the code editor I'll be making use of is the Visual Studio Code over here. Alright, so the next thing I'm going to do now is to create some files in the directory which I've just created. I have this directory here, Python for Pentesters. So I have Python for Pentesters. So I'm going to create, let's create the TCP client. Let's just name it TCP client.py and TCP server.py. Alright, so I'm going to open these files using my Visual Studio Code. So open file, and I'm going to open both of them. Alright, let me open the second one, TCP server. Alright. Okay, so for us to implement this socket efficiently, we need to make use of the Python socket library. So for that, I'm going to import the socket here. And remember, this is for the TCP client. So we're going to start off with the TCP client. So TCP client. So I'm going to import socket, and the next thing I'm going to do is I'm going to name this client socket is equals to socket.socket. Alright, this socket function takes in some parameters. So for that, we are going to making use of socket.afinet and socket.sockstream. Alright, so the sockstream here is for TCP, which I just explained a few minutes ago, transmission control protocol. And this socket.afinet here is for the family. So these are the basic parameters you need to know. The family, which is the socket.afinet, and also the socket type, which is the TCP. So we have it here as what sock stream. Alright, so the next thing we are going to do now is we're going to connect to server. So for that, we are going to make use of our Linux Mint machine here, because that's what I'm using right now to write this code. So for that, let's create some variables here. Host is equals to localhost, and let's make use of 8080. Right, so client socket connect. Now this connect x function takes in a tuple consisting of the host and the port. Alright, so once we are done, we need to send a message to the server. Let's just create something here. Let's just say I'm going to create a variable for message. Message is equals to, just name this hi server, and let's send this to the server. Socket.send. So we're going to encode this using the UTF-8 encoding. All right, so why we are encoding this is this socket operates at a lower level, and they work in bytes. They use bytes to communicate. All right, so since they use bytes to communicate, we have to encode this message here, into bytes. So that's the reason why we're making use of encode and the UTF-8 format. So this is going to encode this message here in the form of bytes. All right, so we're going to send this message to the, okay, so once we are done sending the message to the server, because that's what we are doing here, next thing we're going to do is to let me make the spelling error here. All right, so the next thing we are going to do now is to close the socket once we receive a reply from the server. So let's just make this 1024, and we're going to receive whatsoever thing the server sends to us. We're going to receive it, and let's store it here. Data is equals to is, and for that we need to display the message we received from the server. So message received from server. All right, so let's display the message. So we're going to decode it. Remember, socket, they work at the lower level, so they make use of bytes. So whenever you are sending a message to a server, you encode it, and whenever you receive a message from the server, you decode it. All right, so okay, we have it here. So I'm going to save this. Let's close the socket. Now let's go into the implementation of the TCP server. So I'm going to delete this TCP server, and as usual, I'm going to import the socket library. Alright, so let's make this server socket. It's equals to socket.af inet socket.sockstring. Alright, and the next one we're going to do is we're going to bind the socket to the localhost and port 8080. Could have just is this in a variable, but just leave it like this. All right, so let's make the server to listing for, I think, 5 connections, or let's just make it 4 connections. It's supposed to be sockets, sorry. Socket.listing 5, and I spelled this wrongly, so that's supposed to be bind. Right, so this socket is going to listen for 5 connections. So let's create a loop here, right through, this client, and then the address of the client. That is the client that is going to connect to this server. We need to retrieve the client and also the client address and the port. So we are going to accept the connection.
This is the future.
Now once we accept the connection, we need to print information. Let's say I'm going to make use of this. Let's see, connection from. I'm going to display the IP address and also the port of the client. Now these are stored in a list. So index 0 here is for the IP address, while index 1 here is for the port. Alright, so we're also going to receive some data from the client. So let's say message from client is equals to client dot receive. Let's make this 10 to 4. All right, so I'm going to print message received from client dot format message from clients. Remember, we are going to decode this because like I said, whenever you are sending a message using sockets, you need to encode, and whenever you receive, you need to decode. All right, so message from client dot decode. Okay, so client dot close. Right, so we're going to test this, and let's close this after the loop. Socket dot close. All right, so let's test this. I'm going to save this, and I'm also going to save this. So to test this, we're going to open two terminals here, one for the client and one for the server. So I'm going to open a new window here. So this, we're going to make use of this for the client here. So let's make use of this for the server. So I'm going to Python 3 TCP server.py, and here I'm going to Python 3 TCP client.py. So you see, say receive from client, hi server, and also say message received from server. There's no message received from server, right? That's because we didn't send a message to the client after the server accepted the connection. So for that, we're going to create a message to send to the client. So hello client, let's make this let's also add the IP address and the port for this client. Let's just make use of the IP address only. So we're going to do this. All right, hello from client. So the hello client. So we're going to send this also. Client.send. We're going to send this message, and remember to encode this. So I'm going to encode it UTF-8. All right, so I'm going to save this, and let's run this again. All right, I'm going to use this and this. All right, so this is for the server and this is for the client. So all right, so you see here from the server, the client sends the message to the server, say receive from client, hi server, and on the client side we have the message received from server, hello client 127.0.0.1. Now this is another name for the local host. Either you call it 127.0.0.1 or local host. All right, so let's have to create TCP client and server using Python. So the next thing we're going to do now is to implement a reverse shell using Python. So for that, I'm going to be making use of this Linux Mint here and my Ubuntu machine, which I have over here. So the Ubuntu machine will serve as the attacker's machine, while the Linux Mint machine will serve as the target machine or the victim machine. I believe you know what a reverse shell is. Now, in a reverse shell, the attacker's machine starts up a listener waiting for incoming connection from the target machine or from the victim machine. So in this case, the target machine or the victim machine, which is the Linux Mint here in this case, will establish a connection back to the port that the attacker's machine is using to listen for incoming connection. All right, so to do that, I'm going to close this TCP server here and also the TCP client, and I'm going to create a new file here. So let's just call this touch reverse shell.py. All right, so I'm going to open that file over here. So open and reverse shell.py. So I'm going to open this. So now we're going to start the code of this. So let's import socket, and we are going to be that is the target machine. So the attacker's machine will be sending some commands to this victim machine for the victim machine to execute. So for that, we're going to make use of the subprocess library in Python. All right, so let's define something. Let's say if name is equals to main. That means I want this to execute if it's not imported as a module in that Python program. So if name is equals to main, so let's call this reverse shell function over here. So I'm going to establish that function here. So define reverse shell, going to take no parameter. All right, so import socket. So I'm going to create a socket here. Let's just name this R sock or RS sock, that is reverse socket, reverse shell socket. Why am I getting this wrong? All right, I'm sorry. It equals to socket dot socket dot af inet and socket dot sock stream. Right, so the next thing we're going to do now is to create a loop here while true. Let's receive. Okay, let's connect to the attacker's machine. All right, rssocket.connect x. So before we do this, let me create a host here and also a port. So let's go back to my Ubuntu and look for the IP address for this Ubuntu. So if config, so we have the IP address here as 172.30.1.21, 172.30.1.21. So 172.30.1.21, 172.30.1.21, and let's make support 4444. Right. So we're going to connect to that host and port. All right. So let's receive. Let's say the attacker's machine is going to send some command to the target machine for the target machine to execute. So command is equals to rs socket dot receive. Let us make this 1024. All right. So once we receive this command, we need to execute this command. So for that, I'm going to say let's create a second command here to decode what we receive from the attacker's machine. So command dot decode utf8. Okay, so once we are done, we need to execute this command. So let's just say command result is equals to subprocess. We're going to execute this command here on the target machine. Subprocess command 2. Let's make use of the shell equals to true and stdout equals to subprocess dot pipe. But this pipe, what this thing is going to do now, this pipe is going to create a form of communication or relationship between this Python program and this sub process here. Now the reason for this is because I don't want the output to be displayed on the standard output, which is this, the terminal or the screen. I just want it to be captured by this Python program and handled internally by this Python program here. All right, so once we are done like this, we are going to call this communicate and pass in the index of 0. Now this communicate function here returns first the result of executing this command and also an error message. So let me just show you just like this. Result and error is equals to communicate 0, right? All right, so it's equals to what? Communicate. So now this here is same thing as this. Now the result of executing this command is returned here in this variable rex, and then an error in executing this command is returned here in this variable as an error, right? So now since we want to retrieve this, we need to pass in an index of 0. So because this is just like index 0 and the error here is what? Index 1. All right, so that's what we are doing there. Okay, so once we execute this command, now another thing you need to know is that any result returned by this stop process command is returned in bytes. So we also need to decode it just like we have been doing with the socket. All right, so I'm going to just name this result2 is equals to cmd result dot decode utf 8. All right, so now whatsoever command this target machine execute from the attacker's machine is whenever the attacker sends in a command for this target machine to execute, we need to send the result of this execution back to the attacker's machine. So for we to do that, we need to rs socket dot send cmd result 2. All right, so this is going to send the result of this back to the attacker's machine. Right, so once we are done, we need to close this socket. So rs socket dot close. All right, so we are done with this. So I'm going to save this, and on the attacker's machine, we are going to set up a listener using the netcard command. So we're going to make the 444. So listening on port 444. Now we're going to go back to the target machine, and we are going to execute this reverse share here. So python 3 reverse share.py. So you can see that the command, the function has started already. There is a reverse shell. So let's go back to the attacker's machine to give it a command. So let's display the content of this sensitive directory, of this sensitive file at /etc/password. So I'm going to hit enter. We have an error there. Let's see. Object line, what this is supposed to be line 22. Okay, line 18. Line 18 we have here reverse here rs command result 2. Error, a byte like object is required, not string. All right, yeah, I forgot to encode this. Remember, whenever we are sending message using the sockets, we also need to encode. When we are receiving, we need to decode. All right, so I'm going to save this, and let's run that again. Going back to the attacker's machine to run this listener again, and let's run this again. So for that, I'm going to run this, and back to the attacker's machine, let's display the content of that directory. All right, so you can see the content of this directory. I see a user here, Redhound, that is me, Debian, MySQL, and the rest. We can also display the contents of the home directory. So you can see the content of the home directory here, ls home /redhound, template, videos, pictures, and the rest. You can also display other information which we want as an attacker attacking the target machine. All right, so that is how to run the reverse shell using Python code. Now that you know the basics of using sockets in Python, you can extend this script to build your own tools for port scanning, creating custom backdoors, or interacting with different network services during a pen test. Now, thanks for watching, and please, I hope you come back for more videos, because this is not the only video which I will be making for Pentesters using Python sockets and in fact other Python libraries. So thanks for watching. I hope this video gave you a solid understanding of how to use Python sockets for testing and also for creating a reverse shell. If you enjoyed the video, please like and subscribe, and let me know in the comment what topics you want me to cover next. Till then, happy hacking.